4.10, number 482. Find the antiderivative f of x of the function x. Okay, so antiderivative of some other function, the other function that we're starting with here is sine x cos x in this particular problem. So capital F of x will be the antiderivative, the indefinite integral of sine x cos x. And this is where the trouble comes in, because sine x cos x is a product and we don't have a product rule in reverse for antiderivatives. We actually do, just not yet. In Calc 2, you'll come across what's called integration by parts, and that is basically analogous to a product rule in reverse, but we don't have that technique here, so we're stuck with more limited methods. And here, the method is really just to think about derivatives you've taken in the past that may have had this as the resulting structure, or something similar to it. So it would probably not be so obvious. But one thing we can note in the beginning is that cos x is the derivative of sine x. Right? We see here that within the same integrand, we have the derivative of 1, right, is the other part of this product. Right? So sine x here, and then its own derivative is cos x. And you could look at it the other way too as well. It's true, you could say, well, I have cos x here, and I see the derivative of that is negative sine x, and then you just adjust the negative as necessary throughout the problem. It's true you can look at it either way, but I'm saying it the more obvious way, that sine x is here, and its own derivative, cos x, is right here. Okay, so what does that do for us? Well, it helps us to think about the problem a little bit. I see the derivative, right? Again, this whole thing is a derivative of something, right? But I see the derivative of a piece of it emerging here. So it's kind of like saying you have a function. I'm going to reuse f, the symbol f. This is not the same f that's up here. I'm just reusing the symbol f for function. So you have f here, and then multiplied onto it, you have f prime, right? You got sine x, and then its derivative cos x. So if you think about it like this, these two are related. It's not just sine x and cos x. It's a function and its own derivative multiplied onto it. So therefore, this looks something like a chain rule, right? Something and then times its own derivative. But usually when this happens in a chain rule, right? So it appears a little bit like chain rule. Like a chain rule result. So you don't want to think about products, right? But thinking about chain rule could be helpful. So let's imagine for a moment you had another function, right? G, encompassing this one, right? G prime. This would be exactly what the chain rule is, right? For some function G of f, right? So what do we have? We have something that looks like a chain rule result a little bit. I understand we don't have an outer function G prime staring us in the face. We kind of do, but it's not so obvious at first. But I've got f of x, right, if that's the sine function in pretense here, right? I've got sine function. And then I've got my cosine function right there. That's kind of what we're looking at. There's our product. If I just call G prime right now the first power of x, right? Let's just pretend G prime of x is just x. Then this is exactly our product in here, right? Because I'll be placing the sine function inside the x function, which would just be sine back again, right? It doesn't do anything. And then times the cos function. So if that's the case, then what was originally the g function, right? What was g back before it was differentiated as a composition, right? As a chain rule to get to this state? What was it before? Well, if g prime is x, then that means that g itself must have been 1/2 x squared, right? It's antiderivative. So let's piece that together now. If we believe that g prime being x implies that g itself must have been 1/2 x squared from regular antiderivative rules, then it must be that the original function, right here, before any derivatives were taken, should have been 1/2 x squared, that's g, with the sine function put in. 1/2 sine function squared. Okay? That would be this expression before any derivative was taken. So this is now our guess for the antiderivative. 1/2 sine x squared plus some arbitrary constant c. Okay, so that was a lot of thinking. Let's make sure it's correct. Well, if I differentiate it, what would happen? The 2 would come down, cancel with the 1/2. I'd have sine x to the first power. But to complete the chain rule, I'd multiply by the derivative of sine x, which is cos x. It would give me exactly sine x cos x. It would give me the integrand. Therefore, this is the correct antiderivative. Okay? So this is a way of thinking about these problems. I try to write it very formally here. It's more about just like a thinking process usually than writing it out so formally as all this. But this is where the thoughts would formalize. They would look something like this. Okay?